Dear students, welcome back. This is Dr. Biju Vasudevan. This is the part 3 video for Calculus 1, Math111 for week 12. In this video, we will continue with the chapter 4.2, in which we will discuss the procedures for analyzing the graphs of the polynomials. We have not done this work in the previous video, so we continue with this analyzing the graphs of the polynomials. Before we will start with this theorem 4.25, geometric implications of multiplicity of the roots. If you have a polynomial p of x, can be of any degree, x square minus 4x plus 4 is a polynomial, isn't it? If its roots, what are the roots of this? X minus 2 whole square, isn't it? So the root is x minus 2 and the multiplicity is 2. If the multiplicity is 1, we call it simple root. If the multiplicity is 2, we call it double root. If the multiplicity is 3, we can call order 3, order 4, and so on, isn't it? If the multiplicity of the root x equal to r, here x equal to 2 is the root and the multiplicity m is 2. If m is even number, then the graph, this polynomial is tangent to x-axis at this point. See this the example graph here. See, it will be like this. It will be like this. When the root of this polynomial is of even multiplicity, either it will be concave up or concave down, but it will not cross x-axis. It will be tangent to the x-axis. Tangent x-axis will be horizontal tangent line. That's it at this point, isn't it? And no, this point will not be an inflection point, because at that point the concavity will not change. Next, if the m is greater than one odd number, if the m is odd number, instead of 2, if you find a polynomial x minus 3, x minus 4 to the power 3, the root is 4 and the power is 3, isn't it? The multiplicity is 3. So if m is 3 and greater than 1, then the graph is tangent, see, and also it crosses the x-axis at this point. Also there is a chance of it has an inflection point at that point. See, this is the graph for that one. At this point, if the degree is of odd multiplicity greater than 1, then at this point there is a tangent line, horizontal tangent line, and concave up changes to concave down. So there is a inflection point. Similarly, either this or this, it should be crossing x-axis from one to other side. Fine. Third case, if m is 1, exactly 1, that is a simple root, there is no multiplicity, simple root, then the graph is not a tangent line to x-axis. At the x crosses at this point, the curve crosses x-axis, and there may be or may not be an inflection point. There is no conclusion here, isn't it? There may be or may not be an inflection point. So remember these 3 points about the roots of the polynomial. It's not about critical points or inflection points. It's about roots and how they behave at the roots. Fine. So the graphs have been given. When it's a simple root, it will cross that point. Maybe there is a concave up or down in this point. There is a concave up and down. So this may be a point of inflection, but here there is no point of inflection at this point, right? Next, analysis of polynomials. So you go through this fundamental information about the polynomials, what happens. So I'm directly going to the exercise problems, right? Go to the last problem what we have not solved. Okay, there are 2 problems. Let's start the first one and then 57 as well. Okay, first one 58. See, find the solution of this problem. Actually, what is the question? Read the question carefully. Give the graph of the polynomial. Okay, let's try the even degree. I want to show you one more information before this one. Some important information. See, if the polynomial is of degree 2, it will have one concave up, only one concave. If the polynomial is of degree 3, one concave down and one up. If the degree is 4, there will be 2 ups and 1 down. Not necessary that the polynomial should be in the same shape. It may be in different shape, but the concept is there will be 2 ups and 1 concave down. So it continues on. If you find, see, number of ups are more than the down, isn't it? Degree 5, there will be 3 and 2, isn't it? 3 ups and 2 downs. 3 ups. So this is 1, 2, no, actually 4. Yes, 1 less than that. 2 downs. So if there is a degree 6, you can guess now. Degree 6, then there will be 3 ups and 2 downs. Degree 7 and so on, you can guess. You can guess this one. Now let's go to the exercise problems. So this is a polynomial of degree 2. Degree 2. First one we are solving. And therefore only one concave up, it will be like a parabola, isn't it? Only one concave up will be there, so we have to find concave up. It will be parabola, isn't it? Okay, let's try now. Let's read the question. Give the graph of the polynomial and label the coordinates. See, intercepts, x-intercept, y-intercept, stationary points, critical points, inflection points. We need to find them and then try to draw a rough graph about this one, isn't it? That's what we got to do for the problems. Okay, for problem number 51, first x and y intercepts. You can find x-intercept when you take y is 0. That is the roots of this polynomial, isn't it? So what do you get? X square minus 3x minus 4 is 0, can be written as x plus 1 times x minus 4 equal to 0. So x is equal to negative 1, x is equal to 4. Both are simple roots. Root of multiplicity 1, isn't it? So in this case, multiplicity 1, what is our conclusion? It should cross at this value of x is negative 1 and 4. The curve crosses the x-axis, isn't it? And there may be or may not be an inflection point. So roughly, if you draw this one rough graph, this is 0, this is negative 1, 1, 2, 3, 4. At these 2 points, function crosses the x-axis, this x-axis and y-axis. And what else we get from here? And now these are the x-intercepts. Now let's find y-intercept. How do you find y-intercept? You can get it by taking x equal to 0. X equal to 0, what do you get? Actually, p of x is y. P of x is y, right? So x equal to 0 gives y is equal to 0 minus 4. So y is negative 4. Negative 4. This is negative 1, negative 2, negative 3, and somewhere here negative 4. So at these two, this is the y-intercept. So it will be parabola. It should come down and move up, isn't it? Okay. Next, we will find where will be the minimum value of this function at this point or somewhere. Minimum value of this curve comes at its critical point. So we need to find critical point, which is stationary point again here, right? Because first derivation, let's find f dash of x, that is p dash of x, isn't it? You can consider this is y or f of x, anything. Differentiate it to 2x minus 3. So let first derivation to 0. First derivation of x equal to 0. What do you get? 2x minus 3 is 0. 2x is equal to 3. X is equal to 3 over to 1.5. This is 1, 2, somewhere here. So at x equal to 2, what is y? You have to find the y value. Whether it is lesser than negative 4 or greater than negative 4, we don't know. We have to check. Substitute x equal to negative 5. So at this point, we will find obviously minimum or maximum. So second derivation should be found. What is f double dash of x? F double dash of x is 2. It is always positive, so we get since second derivative. So we know what is second derivative is, isn't it? So when second derivative at the critical point is positive, we get minimum at this point. So whatever the value of x, it is constant. A constant is positive. So at second derivation you get positive. So at the point x equal to 3 over 2, you get minimum most value. So we can find a minimum most value of the function p of x by substituting x equal to 3 by 2 in p of x. So what is minimum of the function value? F minimum is f of 3 over 2. In the original function, replace x is 3 by 2. Get the value. What do you get? Where to write? So let me erase this information and then I write. Then what is minimum value of f? Minimum of f of x. F of x is nothing but p of x, isn't it? This is y, or f of x you can call in this way. F of 3 over 2, which is 3 over 2 whole square minus 3 into 3 over 2 minus 4. What do you get? You try this one, you will get minus 25 over 4, which is lesser than minus 6, isn't it? Minus 6.25 something. Okay, so minimum point, the point at which minimum occurs is x is 3 over 2 and y value is minus 25 over 4. This is the minimum value, but this is the pair of the points at which minimum occurs, isn't it? Which is around negative 6. Now we have to roughly draw this graph. See this graph now. Okay. Here remember, there is this is 1, 2, 3, 4. You can write negative 1, negative 2, isn't it? Negative 3 here. Okay. You can write this as 1, because I don't think there are 6 units. 3, 4, 5, 6. This is negative 6, negative 5, negative 4, negative 3, negative 2. No. So you can start from here. 1, 2, 3, 4, 5, 6. 1, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and so on, isn't it? So the x-intercepts are what are that? Negative 1, x is negative 1 and x is 4. These are the 2 points. Is an x-intercept. Y-intercept is negative 4. And the minimum value occurs at 1.5. When x is 1.5, this is around 6. Little bit lesser than 6. So our curve has to come this way down and reach minimum value here, and then again moves upwards, moving this way outside. So this is the rough graph of the polynomial given. P of x is equal to x square minus 3x minus 4. That's done, isn't it? Now let's go to the next problem, problem number 57. Okay. The question is not complete actually for 51. We have to find inflection points as well. Do you have any inflection point in the graph? Have you seen? No, because the second derivation is 2, which is constant, not equal to 0. So no inflection points. If the second derivation is positive, you will find a concave up. If the second derivation is negative, you will find concave down for the inflection points, isn't it? Okay, you will check it later. Now for this problem, there is no concave up down. Let's go to 57. Note down this problem. We'll take let's continue with the problem here. The problem is P of x is equal to x power 4 minus 2x cube plus 2x minus 1. Okay, the question says you need to find x and y intercepts critical points in inflection point. Then roughly sketch the graph, isn't it? Okay. How to find x intercept and y intercept? Let's try first x and y. Okay, let's find them later. Now this is our y, or this is f of x, or we can call it y, isn't it? Anyway, so what is first derivative? Let me find critical point and inflection point first. F dash of x, x cube 4x cube minus 6x square plus 2 is equal to 0. Yeah, no, this is actually second derivative. First derivation we have to take it to 0 to find the critical point. Second derivation is 12x square minus 12x. We have to take second derivative into 0 to find inflection points, isn't it? Now f dash of x equal to 0 gives critical point for critical points, isn't it? See please. 4x cube minus 6x square plus 2 is 0. And you see, x is equal to 1 is a root here, because when x equal to 1, this will be 4 minus 6 plus 2 is 0. So x is 1 is a root. This can be found by substitution. You can start from x equal to 1, try x equal to negative 1, and x equal to positive 2, x equal to negative 2 to find the first root. So by trial and error method, we have chosen x equal to 1 is a root. So we remove this root by using this division. Synthetic division into 4 negative 6 x times 0, constant is 0. We have written the coefficients. And now 1 is the root. We have found right 0 here. 4 0 is 4. 1 into 4 will be positive 4. Negative 2, when you add the sum, multiply with 1, you will get minus 2 here. Add them, you get minus 2. Multiply with 1, you will get minus 2. So this is 0. This will give you this reduced equation, second equation, isn't it? Second order, second degree equation. X 4 x square minus 2x minus 2 is 0. Now we have one root for this polynomial. This is actually first derivation, not the original polynomial. When I simplify or take a is equal to 4, b is equal to negative 2, c is equal to negative 2, in this equation x is equal to minus b plus or minus root of b square minus 4ac divided by 2a. You take 2 plus or minus root of 4 minus 4 into 4 into minus 2 divided by 2 into 4. In this way, if you continue, you will get x is equal to 2 plus or minus 6 divided by 8. So x is equal to 2 plus 6 over 8 will be again 1. X is equal to 2 minus 6 over 8 will be minus 1 by 2. And the first root we have found by trial is x equal to 1. So there are two roots for the first derivation. So the critical points are x is equal to 1 and x is equal to negative 2. So we have answered the critical points, and then points of inflection. Go to the second derivative. What is second derivative? F, let the second derivative to 0 for inflection points, isn't it? What was our second derivative? Can you remember? Can you recall it? It is 12 x square minus 12x is 0. When you take 12x outside, is x minus 1 equal to 0. So x is 0 or x is 1. So inflection points we have found. Therefore inflection points are what? X is 0 and x is 1. That's it. So x is 1 is a critical point and a point of inflection as well. So at this point, x is 1 the critical point. We will check whether maximum or minimum occurs later on. Okay. At the critical points, at every critical points, we will find whether maximum or minimum occurs. Next, what is the function given to us? You will write the function and check critical points. You should remember the critical points. Critical points are x is equal to 1 and a negative 2. This is critical points. Inflection points are x equal to 0 and 1. X is equal to 0 and 1. We remember this is inflection points, isn't it? Okay. Remember this one. Now, second derivative f double dash of x is 12x square minus 12x. So f double dash of 1, the critical point, what is second derivation? If the second derivation is positive, you get minimum. If the second derivation is negative, you will get maximum. So at 1, you will get 12 into 1 minus 12. It is 0, neither positive nor negative. So no maximum, no minimum. Isn't it? We can find. And at the second point, f double dash of negative 1 by 2. So 12 into negative 1 by 2 whole square minus 12 into negative 1 by 2. What do you get? Use calculator. Are you getting positive or negative? This is 12 into 1 by 4, which will be 3, minus and plus 6. So it is positive. So at x is equal to minus 1 by 2 critical point, we get minimum, because positive f double dash is positive, minimum value. So minimum value of the curve occurs at x is equal to negative 1 by 2. All this should be informed written on our graph, isn't it? Okay. And I would like to draw the graph here. Roughly you will get it. Okay. Let this be y-axis. This being x-axis. So this is x and this is y, and we should write negative 1. Let this be 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, 1 and 2. You can come down to negative 1, negative 2, negative 3 and rough. Now the minimum most value occurs at x equal to negative 1 by 2, isn't it? Okay, we have not found one important thing from the given problem. Actually, we have not found what is x and y intercepts. We have found critical points, and we have found inflection points. We will write them on the graph. Here the critical points are x is equal to 1. This is a critical point. This is the critical point, isn't it? X equal to 1, and x is negative half. It's here, and we know the minimum value occurs at this point. At this x equal to 1, there is no minimum maximum, so minimum value will be somewhere in this line downwards, right, somewhere here. Okay, let's go back handy. Find points of inflection. What are the points of inflection? 0 and 1. X equal to 0 and x equal to 1. Again, x equal to 0 here, points of inflection 1 here, isn't it? 1 is already a critical point. Okay. At x equal to 0, you can find a y-intercept. So go back to the original function, write the function again, y is equal to x power 4. This is a given function. Check. When x is 0, you get y-intercept. All the three elements will be 0, y is negative 1. Let's do it. When x is 0, y is negative 1. When x is 0, y is negative 1. It's here, isn't it? So the curve, so what about the roots of the original function? Then we will understand. See, it's a degree, the equation is of degree 4, so there will be 2 concave ups and 1 concave down by the information we have seen, isn't it? And 2 concave ups, so there are 2 inflection points, we know, 0 and 1. In this check, we will check where the concave up and concave down comes. Before that, what is x-intercept? X-intercepts are the roots of this one, isn't it? Take y equal to 0, solve this one by the same method we have solved the first derivation. How to solve this one? Equation of degree 4. Take first trial and error gives x equal to 1. Is a root. Is a root. When substitute x equal to 1, it will be 1 minus 2 plus 2 minus 1. It is 0, isn't it? So it's a root. So when you remove this root by using synthetic division, this is 1 cube minus 2 square 0 x positive 2 constant negative 1 and 1 is 0, root 0 here 1, multiply with this 1 and then 1 and 1 will be 1, add them minus 2, multiply with this 1, you get minus 1, add them minus 1, multiply with 1, it will be minus 1, add them, will get 1, multiply with this 1, it will be 1, at the end is 0. So now the degree will be reduced. This one will give you x cube minus x square minus x plus 1. Again repeat this one. So x equal to, again, x equal to 1 is a root. Because when you substitute x equal to 1, this will be 1 minus 1 minus 1 plus 1 is 0. So what you get is, reduce it to find the reduced form 1 minus 1 minus 1 1 0 1 0 0 minus 1 minus 1 0. So this is square term, this is constant term. X square minus 1 is 0, x is 1, x square is 1, x is plus or minus 1. So here x is 1 is a root of order 3. It is a multiplicity 3. So when you get x equal to 1 is a multiplicity 3 is greater than 1, odd root, I mean, see, you find here that here x is equal to 1, x minus 1 whole cube and x plus 1, isn't it, are the factors. So x is equal to 1 is a root of multiplicity 3, which is m, isn't it? So the multiplicity is 3, so there will be, what is the root? You can check back to this PowerPoint. You have seen this one right now, you remember it, just here. When it is odd number, m is odd and greater than 1, x-axis It is a tangent line to x-axis and crosses the x-axis. Also has an inflection point there. Isn't it? That's what we should remember, inflection point there. Okay. Now down. Let's go to the board. So we have collected a lot of information. X electricity. We have to submit them on the graph. X intercepts are +1 to -1. So the curve intersects x-axis at +1 and -1. -1 is the simple rule, so it crosses x-axis at this one, and here this one will give you f of -1/2 will give you the minimum value, isn't it? You can check in the original function. You substitute -1/2, you will get -27/16, which is more than 1.5, isn't it? -1.5. So it will be if you write exactly, -1.6 or something, -1.6875, -1.7 something. So it will be here. So at this -1.2 you get minimum value of the function here. So the function crosses x-axis at -1 because x-intercept is -1, reaches minimum value here and moves upward to cross y-axis here, and then it should cross here, then it goes upwards. So we have to check concave up and concave, whether this is one concave up and this is second concave up, this is concave down. There are in our x-axis there are two concave inflection points. One is 0 and 1. So second derivation in this interval, second derivation in this interval, second derivation in this interval. Check yourself. You will find second derivation in the interval. Take some negative value between 0 and infinity. You will get positive, greater than positive, isn't it? So it will be concave up here. In this interval, take negative half. It's negative here, so concave down. We already found it, negative value here, so it is concave down. In the interval 1 to infinity, take f2, it will be again positive. So concave up here, concave up from 1 to infinity, it will be concave up. Here 0 to 1, it will be concave down. This is the rough graph of the problem. Thank you very much. That's the end of this video.